maximum point. The maximum point is essentially the highest point the quadratic graph reaches. It is shown here by a red line. The minimum point is the opposite of the maximum point and is the lowest point the quadratic graph reaches. It is shown here by the red dot at the bottom of the graph. Quadratic functions. A quadratic function. The graph for quadratic function is a parabola whose axis of symmetry is parallel to the y-axis. Think about how you've done linear inequalities on a number line. For instance, they'd ask you to graph something like x less than 2. How did you do it? You would draw a number line, find equals part, in this case x equals 2. Mark this point with an appropriate notation, a dot indicating the point x equals 2 wasn't included in the solution. And then you'd shade everything to the right, because greater than meant everything off to the right. The steps for graphing two variable linear inequalities are very much the same. This graph is the solution to y equals or is greater than 2x plus 3. Just as for number line inequalities, my first step is to find the equals part. For two variable linear inequalities, the equals part is the graph of the straight line. In this case, that meant the equals part is the line y equals 2x plus 3. I've already graphed the equals 2 part. It's just the line. Now I'm ready to do the y less than part. In other words, this is where I need to shade one side of the line or the other below. Now think about it. If I need y less than the line, do I want above the line or below? Naturally I want below the line, so I shade it in. And that's all there is to it. The side I shaded is the solution region that the exam board wants.